Hello, welcome to Coffee Break with Microchip Technology. Coffee Break is our ongoing forum in which we discuss new and evolving technology all in about the amount of time it takes to drink a cup of coffee. I'm your host, Eric Glatfelter. Joining us as usual is Aliyah Fahout, our moderator. Aliyah, welcome back.
Thanks, Eric, and hello, everyone. Thank you for joining us today. We are currently live on YouTube, Facebook, and LinkedIn. You can participate in today's episode by leaving your questions and comments in the chat or email us at livestream@microchip.com after the broadcast. Don't forget to follow us on LinkedIn and subscribe to our YouTube channel. Back to you, Eric.
Thanks, Aliyah. On to our topic for today, why standalone memory? Joining me in the studio is Eric Moser, Product Marketing Engineer here at Microchip. Eric, welcome to Coffee Break.
Thanks for having me. It's great to be here.
All right, let's tell people why standalone memory. First, in this context of a system design, what do we mean by standalone memory?
Yeah, great first question. So standalone memory is really any storage device that exists in your embedded system outside of the core microcontroller. So in pretty much every embedded system, there is a microcontroller, and that microcontroller has embedded memory integrated into it. So the standalone memory is just anything outside of that.
Okay, so we really want to differentiate it versus embedded memory or integrated memory.
Yeah, exactly.
Okay, so how much density or capacity are we talking about here typically within the microcontroller or typical microcontroller versus standalone memory?
Yeah, so if you look on the screen, I put up some example capacities that you'd find on a high-end, maybe an 8-bit microcontroller. At the bottom you see, might have a 1 megabit of flash, 8K bits of EEPROM, and 64K bits of SRAM. But with standalone memory, you can get way more space with that.
Okay.
So,
and where as you're thinking about how to partition your system design, where in that design process would you make the decision to use standalone memory or count on completely integrated or embedded memory?
yeah, so this is a pretty common situation that we run into a lot. And so a lot of times what happens is a designer or some businesses designing, they're creating a new design, and they usually start with the microcontroller, and because that's what gives you most of the core functionality in your design.
Okay.
And then maybe they get halfway through their design process or farther along, and then they run out of space on maybe the flash, or maybe they run out of space for their code grows too big, the requirements change, they have to add more features, or they run out of space for their calculations and their configurations. So then what do? So the intuitive thing to do that a lot of people think of initially is to upgrade to a new MCU or something that has more storage on board. However, when you upgrade, you aren't just paying for that additional space, you're paying for all of that additional functionality that comes along with that. So a lot of people end up going with standalone memory in that situation.
Okay, so if you upgrade, you may get more memory, but you may also then be paying for additional peripherals that you didn't spec in the original design or something like that.
Yeah, exactly.
Okay.
And that can be expensive. And
Sure.
we actually had one customer recently who was making a revision to an existing design. So it was a design where they already had a microcontroller that they were happy with. They didn't want to change the microcontroller, but they were adding software features and things like that. And so they ran out of code space. So we helped them add a standalone flash to their design. And that does a few things. It not only does it help them avoid the cost of an upgraded MCU for every board, but it also helps them avoid an extensive redesign.
Sure.
And it also future-proofs their design.
Okay.
So instead of upgrading the microcontroller every time you do a revision, you can just upgrade how much flash you have.
Okay.
And a lot of times, you can get a 1 megabit flash in the same package as a 64 megabit. So it's just like a drop-in replacement.
Right. Okay. So what are the situations or the circumstances where we see standalone memory being opted for most typically?
Yeah. So we get people asking us, like, what are the applications and industries that you see memory the most in? And I would say that, memory is one of the most general purpose types of devices that go into your design.
Yep.
So it's really hard to attach it to a specific industry or application. You might be able to look at like a niche type of memory. A lot of niche types of memories work really well in specific situations. You could also look at the subtypes of memory and see, what situations do those work best in. And I think that's really getting into the trade-offs between the different types of memory.
Yeah, so let's talk about that. There's different memory types. There's different memory types that are integrated and different memory types that are standalone. So again, thinking about the design considerations when you're thinking about how to partition the system, what are the main trade-offs that you want to consider?
Yeah, so when you're looking at embedded systems, there are really three major types of memory. There's flash, EEPROM, and then there are different types of RAM. And they all have their own advantages and disadvantages. But to start with flash, tends to come in the largest densities available. And so density is just the capacity of the chip. It's how much it can store in bits. It's usually in megabits or kilobits. And so flash is really great for large files because it can store a lot. However, it doesn't have as high of an endurance specification. So some types of memory like flash and EEPROM wear out, and flash wears out, so you don't want to write it too often. So it's really good for things like images and audio files and things like that are large. They don't change very often. That you don't have to access, or you don't have to change them too much, but you can read them as much as you want.
Okay.
And then you have something like EEPROM. So EEPROM, it comes in smaller sizes, but it's a much higher endurance. So it can handle a lot more read-write cycles. And endurance is just how many cycles it takes before it wears out. But EEPROM is great for things like variables, configurations, parameters, things like that. So it's almost like the data that the software is storing.
Okay.
And then finally, you have different types of RAM. And so most types of RAM they have infinite endurance. So that means they don't ever wear out. You can write them as much as you want, as frequently as you want. And so you're probably wondering, okay, well, why not use RAM for everything?
Right.
It sounds like the ultimate. But most types of RAM are volatile. So that means they lose data when the power is lost. So they tend to be really good for things like scratchpad, for any type of, you could really use it for anything. One situation I like to talk about is using it to buffer flash. So you use it as an intermediate step for your data and calculations and stuff. And then when you detect a power loss, you could transfer it over to the flash.
Okay.
You save yourself some write cycles on the flash, and the flash lasts longer.
Okay. All right. So you mentioned those are the three main types. Are there other newer types or niche types that are worth considering?
Yeah. So when a lot of people think of new types of memory, they think about FRAM and MRAM. So those tend to be, a hot topic of discussion for a lot of people because they tend to view it as a newer type of memory. And FRAM is ferroelectric RAM, which is misleading because it has nothing to do with iron and it's not affected by magnetic fields at all, which is a good thing. But it's basically a RAM that's non-volatile, so it doesn't lose data on power loss. So it sounds even better where
Regular RAM.
Yeah, it's like RAM, but it doesn't lose the data. So what's the catch? And the catch is it does have endurance, although the number's pretty high. It's usually about 1 trillion cycles. However, the reading it does wear it out. So you do have to take that into consideration. It is also expensive to manufacture, so it's kind of expensive to buy it. So it's really only good in situations where you cannot afford to lose data at any point. You don't have time to transfer that data over to another memory. You need extremely fast erase and write times. So that's what it gives you. And then the story is somewhat similar with MRAM. MRAM is also a non-volatile RAM. but it does not wear out. Okay, so it sounds even better, but it is affected by magnetic fields because it uses magnets to store the data. So that's kind of a deal breaker in a lot of applications.
Right.
And then we have stuff, so in terms of uncommon types of memory, we have stuff like one-wire EEPROM, and that's just a normal EEPROM, but it's on a one-wire bus. And the one-wire bus is really cool because you only need 2 pins. You need ground, and then you need a power pin, but that power pin also acts as clock and data at the same time.
Okay.
So this tends to be really great for things like consumables or attachable applications. So imagine something like a medical device where you have a vacuum tube that plugs into it. The vacuum tube doesn't have any electronics in it, but you can put one of these one-wire EEPROMs in it. When it plugs into the broader system, the system turns the EEPROM on, it reads it, it makes sure it's an authentic component. You can use it for authentication.
Okay.
It's also used for calibration in, say, like a fiber optic data center. In data centers, they use a lot of fiber optic cables.
Yep.
A lot of those cables have electronics in the connector to calibrate the connection.
Okay. Okay. Interesting. So, so with these different types, you've decided to use a standalone memory of some type. What else do you need in the system? What do you need to think about as far as deploying it in your system? Okay,
so you're always going to need some central controlling component. So obviously, you're always going to need a microcontroller. You can use an MPU, a microprocessor, or an FPGA. You also need to make sure that you're using a common embedded communication protocol, the one that you need for the memory device you need. So like I2C or SPI. Pretty much every modern microcontroller comes with I2C and SPI.
That'll be a standard peripheral in most modern MCUs.
Yeah, exactly. Okay. And if you're using an MPU or an FPGA, those aren't going to usually come with that circuitry built in, so you have to find a way to make that work. Another consideration is so the type of memory you're going to use will have an impact on it. So if you want to use a serial flash chip, pretty much every serial flash uses SPI. So you have to make sure you accommodate that and use SPI. And then finally, you should consider your board space as well. And it sounds weird to say, but we have seen a few situations where board space can be a problem. For example, in something like a hearing aid, where you have absolutely no space whatsoever, you might not have space to add a standard EEPROM in that standard package. So one workaround to that is a chip scale device, which is just the chip itself with some solder balls on the bottom side of it. So there's pretty much no packaging around it. And most manufacturers will sell this to you. They will do this as an option. You just have to make sure you're placing large enough orders for them to do that. So,
all right. So talking about ordering, what does Microchip offer in this space? We've got a range of memory types. Can you kind of walk us through that?
Yeah, sure. So at Microchip, we have a lot of different options. We have serial EEPROM, and then we have our serial superflash memory technology. This is our NOR flash product line. And then we also do serial SRAM, and then we do a lot of older stuff as well still. We still sell parallel EEPROM, parallel flash. We even still sell OTP EEPROM. And a lot of people still need that stuff, and at Microchip we have our policy of customer-driven obsolescence. So as long as people are buying it, we'll keep making it.
Okay, so how about the packaging options? You mentioned chip scale. Obviously, there's a range of packaging options as well.
Yeah. So with the packaging options, the most common packaging that you'll see with memory is usually SOIC. We have TSOP. We have SOT23 stuff. And then if you want to go to the newer, smaller types of packages, we have a lot of different variations of DFNs. We even have some stuff with ball grid arrays. And then with the old stuff, we still do PDIPs and SOIJs, stuff like that. So people don't want to change footprints.
Sure.
we still make it. So.
Yeah. Okay. And how about tools?
Yeah, so I think a lot of people know about Microchip's PIC development tools like MPLab and stuff like that. For memory, so I mean, everybody, a lot of people want to add memory to their design, but the evaluation kits available for memory are hard to come by. They're usually very, very memory device specific. So we came up with something called our Memory Explorer evaluation platform. And this is our new graphical user interface that our applications team just released recently. And it works in conjunction with our evaluation kits for our serial EEPROMs.
Okay.
So we have this USB-based kits that you can just plug into your laptop, and they have a little zero insertion force socket on there, so you can switch out different EEPROMs, and then you open up the GUI, and you can program it and turn different features on and off, and just try it out and explore.
Okay. So one board for a wide range of devices.
Yeah,
So,
exactly.
yeah, awesome. Okay. All right, Eric, thank you so much for walking us through that and sharing some of your expertise. At this point, let's go to Aaliyah and see if we have any questions from our viewers today.
Yes, Eric, we do have a few questions. The first one is, does anybody still make parallel flash or EEPROM?
Yeah, so a few different manufacturers still make parallel flash and EEPROM. At Microchip, we do it. As I mentioned, it's something that it tends to be pretty common in a lot of older industrial types of applications where the customer doesn't want to continue to redesign, or maybe they just don't want to spend the resources on doing it, and what they have works. So we still make that, and people can come to us and purchase that stuff.
Awesome, thank you. The second question I have for you is, how do I get one-wire EEPROM working in my design?
Okay, so one-wire EEPROM. So one-wire is really a classification of a bunch of different unique protocols. So one-wire is not a standard. Every company that makes one-wire pretty much has their own one-wire type of protocol. They're all slightly different. So if you do want to use one-wire in your design, just make sure to do some research on the product line you want to use. Look at the data sheet, look at the application notes, make sure you understand what goes into designing that. It's always going to be better if the manufacturer offers some sort of a development kit or evaluation kit to help you get started. At Microchip, we have our single wire EEPROM evaluation kit. So that's something that's one of those USB-based kits that we were talking about. That's something you can just plug right in, and it's easy to get started with that.
Okay.
Awesome, thank you, Eric. I have a question for you from YouTube. We have a question about the difference between a microcontroller and a microprocessor. What is the difference in this context?
Yeah, so a lot of times a microcontroller is really just a microprocessor, but it has all of this additional supporting circuitry on board. And so it has all the memory you need, it has all of the regulators you need to regulate external power down. Microprocessors tend to just be a processor, and they tend to be for much higher performance types of applications. And so if you have a microprocessor, you have to consider, the different components that you're going to need to support that, and they're going to be external devices usually. And so, like on the screen, you can see one of Microchip's system on modules. It's a microprocessor, but they added all those additional chips on board to support it, and it acts as one device basically.
Awesome, thank you. The third question I have for you is, could you talk more about EERAM?
Yeah, so one of my slides previously, I was showing serial EERAM, and that is Microchip's version of it's Microchip's version of non-volatile RAM basically. So it is, when you're using it, it operates as an SRAM, and so you can it has infinite endurance. You use it for your data. It's a very similar situation to buffering, buffering a non-volatile memory. You use the SRAM, and then when it loses power, there is a pin on that device that connects up to a capacitor or something. And so when the power is lost, it automatically will transfer that data from the RAM over to the EEPROM. And then when power comes back online, it automatically moves the data from that EEPROM back to the SRAM. So you can use it like an SRAM, it operates like an SRAM, but it's non-volatile and it stores your data on power loss.
Thanks, Eric. Another question for you is, what tools can I use to add memory to my design?
Yeah, so I did talk about Memory Explorer a few times. So we have our Memory Explorer user interface, which is available now on our website. And if you go to the page for our development tools, you'll find the download for it there. But it's just a way for you to, plug in different EEPROM devices to the socket on the evaluation kit and explore the different features. You can program data in there, you can load hex files, it even lets you generate random data to load into the EEPROM. And then you can turn on write protect, you can vary the voltage and the frequency, and then we have our SPI and our I2C kit. So from Microchip, we have a pretty solid evaluation kit offering to get you started. It seems hard to find other stuff available out there for other types of memory. So we're pretty proud of what we've created.
Awesome. I have another question for you from YouTube. This one is, for program memory, what processors features are required to support the serial flash?
So if you're using a serial flash, your microcontroller has to have an SPI module for your standard SPI flash. Some of our flash devices they have they support dual and quad interface SPI. So those are just like SPI, but instead of using the 1 IO, it uses 2 or 4 IO. So you have to make sure your microcontroller can go fast enough to support that and has the IO to support that as well. And then, with the flash, you just have to make sure that, check the data sheet, look at the program and erase times, and you want to make sure you're giving the chip enough time to do what it needs to do when you write data or you erase something. You don't want to be trying to write and read from it while it's still in operation, so that's not going to work.
All right, thank you, Eric. Those are all the questions I have for you today. So thank you for answering the viewers' questions. And for the viewers, if you have additional questions or comments, you can email us at livestream@microchip.com. And don't forget to follow us on LinkedIn and subscribe to our YouTube channel. Back to you guys.
Thanks, Aaliyah. Thank you again, Eric. And also thank you to our viewers for taking some time out of your day. Please visit us at microchip.com/coffeebreak. You will be able to see our last episode of the season upcoming in 2 weeks. You'll be able to sign up for notifications for future seasons. And you can also look through our library of previously recorded sessions. So we hope to see you during some of our next episodes. Thank you again. Good day.